There are tons of different hair colors out there, ranging from brown to black to red to blonde, but how do we know how common each hair color actually is, or how likely a certain hair color is to be passed on to the next generation? Well, let's simplify this a bit to start. Say we've got a group of 100 people. Each person has either brown hair or red hair. Their hair color is determined by two alleles, which are genetic information that determine a trait. In this case, alleles will be represented by M&Ms. Now, if a person has two brown M&Ms, they'll have brown hair. If they have two red M&Ms, they'll have red hair. But if they have one brown and one red M&M, they'll still have brown hair. This is because in this scenario, brown is the dominant allele, and it covers up the red hair trait. Looking back to this population of 100 people, we could just count how many people have brown hair and red hair, but this wouldn't tell us everything. A brown-haired person could have either two brown M&Ms or one brown and one red M&M. This brings us to the topic of the Hardy-Weinberg principle. Fancy term, right? It's actually not too complicated. By the end, we will be able to fill out all these checkboxes, but first, we're going to need some simple math. Let's say the fraction of brown M&Ms from the total is B, and the fraction of red M&Ms from the total is R. This means that B plus R equals 1. Now, let's make this a bit more interesting by squaring the equation. We now get this. B squared plus 2BR plus R squared equals 1. But what does this mean? Remember that B is the fraction of brown M&Ms from the total. In other words, it is the probability of getting a brown M&M. This means that B squared is just the probability of getting two brown M&Ms. Similarly, R squared is the probability of getting two red M&Ms. So what is left, 2BR, is a fraction of people with one brown and one red M&M. We can finally put our knowledge to use. Let's say out of our population of 100, we know that 16 have red hair. What can we get from this? Going back to our equation, we know that 0.16 equals R squared, or the fraction of people that have red hair. This means that R equals 0.4. Plugging that into our first equation, we get B equals 0.6. Now, we can figure out that the number of people with two brown M&Ms is 100 times B squared, which is 36. The number of people with two red M&Ms is 100 times R squared, which is 16. And finally, the number of people with one brown and one red M&M is 2BR times 100, which is 48. We did it! Each of these checkboxes is finally filled. But what is the application of this in real life? The Hardy-Weinberg principle can allow scientists to follow a certain genetic trait as it flows through a population of an animal or plant. It can allow scientists to follow a genetic disease through a group of people. The possibilities are endless. But for all this to happen, there are 5 preconditions that need to be set. And this is where it begins to get complicated, and I'm just about out of time. That's why I encourage you to discover some more on your own. I've been Jonathan Siskind, and thanks for listening.